Good evening, everybody, and welcome to our first ever Zoom attempt at our annual MTRA Tech School and tech discussion here. Now, there's a lot of really smart guys working behind the scenes to make this thing work, but I am not one of them. So bear with us as we do this. As Paul sent a message there, you use that chat feature if you got questions to bring them up, and we'll look into whatever you got there. Keep in mind that ordinarily this takes us all day to do it, and we're going to attempt to go through it a lot more quickly here. If this works like we anticipate it will, and since we seems to be getting a really good response from this, we'll have a lot more of these more frequent discussions where we can all log in and we can do this without everybody spending a lot of money or time to be in different places. We'll be able to do this a lot more efficiently, a lot more quickly, a lot more free. So, uh, that being said, as we get started and we go through this, I want to remind everybody again that you'll see all kinds of different trees, everybody's. There are certain people, or we want to some for this guy, we're gonna stab him or something. It happens to be that here's a good example of what it is that we're discussing, and whosever truck it is, it is. We've got collectively several hundred years of experience under the MTRA's belt of going to all these different events and all of these different uh, accidents, things that have happened, close calls, things that we've gotten away with. There's a lot of things that we over the years we've learned to put into this rule book. And it used to be every time there would be more and more rule changes at the end of the year. And fortunately, we've narrowed that down, and there hasn't been a lot recently. But there's always a really good discussion, and this is our time to do that, to go through these things, talk about things that may have happened this year, things that maybe we want to look at, things that have occurred as the sport continues to evolve, more tricks, more different types of things that are out there, different things that are happening. Certainly, we run in some circles, other people run in other circles, and this is a discussion here that everybody can come in on, say I saw this or I saw that, and these are things that we can help make the sport safer for everyone. So like I say, don't there's everybody's trucks are used in these things. Don't be offended if your truck comes up there and think that somebody's trying to make an example of it, because I know ours are on here a bunch. And that's just the way it is, just because we happen to have good examples of something that happened. So all right, with that, we'll just follow along like we usually do through our MTRA Tech sheet, and we'll kind of go along and discuss a few things so that you know what we're looking at and what we're looking for. And if you have a question, type it in there. The guys are watching for that. We'll get it, and we'll hopefully get an answer up for you, or we'll bring it into the discussion. Or bear with us, because I don't really know how this works, but like I say, there's some really smart, brilliant guys here behind the scenes that are helping make this thing work, and they do. So they'll get us in there. So if you got something to say, get in that chat, and we'll get it in there. All right. So here we go.
Very quickly, let me reiterate. We are going to take a few questions as we go through this. I'm sure there'll be. I recognize that the overwhelming majority of you here have never been to one of our tech schools before, and we tend to get into the weeds on a lot of things that are really finer details. But in the interest of time, we're going to try to go through this as quickly as possible and still hit all the highlights. And for myself, I would like to make one statement here at the beginning, because this is something that we have been uh, accused of in the past, and I want to make this very clear that nothing we are about to present is an attempt to single anyone out. It's not an attempt to suggest that we're infallible. We all make mistakes. And this is all being done within the interest of advancing safety for everyone, including ourselves. We have all done things that in hindsight we weren't proud of, and that we would like to have done differently. So with that, let's move forward and see if we can learn a thing or two about some of the things that the MTRA has done in the past and what we plan to do in the future. The way we're going to run this is kind of as going down the inspection sheet. Although this isn't necessarily a tech school per se, this is more or less the way the inspection process is run. And that's just a good way so we can go through and kind of not miss any of the major points of the technology that needs to be in place in order to perform in a safe manner.
All right, so first we're talking about the external check that when we'd walk around the truck and look at, I mean, make sure everything's right. Just the basic external examination, if you will, of the thing. The rear kill switch. Of course, one of the first things that needs to be tended to in an event of an accident, the track officials are going to come out, shut the thing off so that they can make sure that everybody's, first of all, that nothing else is going to move, or something, the driver's not going to try to start something or whatever while the recovery's in process, or while there's people trying to rescue people on the scene, or whatever the case may be. So here you can see the guy speeding up there on the quad to go to the back, pull the kill switch, and then check and make sure everything's all right. So that rear kill switch has to kill all the power, the fuel pump. If there's an electric one, I don't know that anybody's running electric ones anymore, but any other electronic stuff, we want to make sure. And you need to be able to reach that, even if it's upside down. We want a high visibility color on it, and the direction, if it's pull to shut off or push to shut off, we want that marked. Remember that it's got to be able to reach even if the thing's upside down. Right there in the back, some kind of direction to it. If it's a bright color, everybody see it. Everybody's pretty familiar with it. There are some of the T-handle ones out there like this one that some people have. And we're going to have a race and somebody's going to wreck, I think. That wasn't supposed to happen.
Hey, he crashed too. Everybody stay back. Should I run out there with some MTRA?
And here's some guys running out there, and it doesn't look like anybody's looking for the switch. Yeah, there we go. That guy's going. There he goes, and he's going to the switch. So get the truck shut off, and then we can tend to it, and we know that nobody's going to start anything or try to move or do anything else while there's people tending to the emergency situation there.
One of the reasons for that is that sometimes in a rollover, you'll have, let's say, like the rear steer pump or something that will hang up and run. And, there may be situations where there's fuel spillage and you don't want any of the electronics to cause a spark or anything to cause a fire. So that's why it's really important that's the first thing. Even before checking the driver, the first thing needs to be done is to hit that kill switch.
Less than the chance of a flare up. Yeah. The batteries, we need racing style batteries, dry type batteries, these AGM batteries. We don't want car batteries, just normal car batteries full of lead acid. And and they got to be covered. You see here, these are covered with Lexan material over the top. The idea being, if something gets mashed down on top of them, if they're or if the guy wrecks on top of the cars or whatever, some materials from the chassis fold in on top of them, whatever might happen, it's not going to arc and cause a fire. Just like what we were just talking about, except this is before, obviously before that shut off. So we can't have anything touching them terminals. So we want those batteries secured. They can't fly around. We don't want them, where they can get away or get loose. Anybody's ever picked up a car battery knows they're heavy, and we don't need them flying around. So they got to be mounted good. We want to make sure they're mounted securely. So they can't move and they're covered, and they're the correct
not
type.
non-conductive material as well.
Yeah, don't not a sheet of metal over the top of them. That obviously wouldn't be any good.
Sorry, Tim, just had what I thought was a decent question. How thick of that Lexan over the battery? Is it 1/8 inch or?
Yeah, I think that's all that we've in the past we required at least an 1/8 inch, and in some cases it needs to be fairly flexible so that it can get tucked into the situation. Especially nowadays in a lot of today's trucks where the batteries are down in the middle or in the belly or something, and you got to kind of twist the Lexan to get it up in there to cover it. So the main thing we want is just something over the top of it, secure. That's not going to allow those terminals to get hit by, like I say, if it's a piece of a bed mount or a hood mount, or depending on where the batteries are, something that could fold in there on top of them and cause a fire.
Right.
The crossover relief valve is an arm saver. There's a few different types. Here's one that's not directly mounted to the orbital. There are other ones that are mounted directly to the orbital. Its function is to intercept a spike that's coming down the line before it gets to the driver, and it diverts it. I don't know, I guess to the other side. That's how it works, and thus the crossover. But it keeps the spike from getting to the driver. A lot of drivers in the early days, myself included, had get their hands hurt because it would rip the steering wheel out of your hands before this was invented, and this fixed that problem. So it's a genuine hand and arm saver and thumb saver. Anybody that ever had a steering wheel ripped out of their hands, you got to have this thing. Attempting to race without it is a disaster. You will get hurt. So they're like I say, there's a few different types. There's two different types. The indirect ones that'll be mounted somewhere on the chassis with lines going between the orbital steering box and the steering cylinders. You'll see it. It could be mounted on a 4-link bar, could be on the chassis, could be on the axle housing itself. Guys mount them in different places. And the other kind mounts directly to the orbital. That's that square block that you see there, that the hoses are attached to. The hoses are coming out. The orbital is the black valve, the black steering valve there. Then there's that square block, and then the fittings. That square block is what we're looking at. There's a series of O-rings that in the bottom that seal it to the black orbital steering motor there, and that will also accept or intercept, I should say, any spike and vent it to the other side, cancel it out, so to speak, so that it doesn't rip the steering wheel out of your hands.
I want to also point out that the inline mount, the lock valves for the rear steering look very similar. If you have to really know what you're looking at to be able to distinguish the two. So it's important sometimes that you trace the lines back to if in other words, looking under the truck, be sure that you can visually see that it is in line from the orbital box down to the steering rams, that it's not going to the rear of the truck, because that's a lock valve.
And its purpose is completely different.
Yeah, they're actually completely the opposite. Exactly. The crossover relief valve is effectively a pressure relief valve that just lets the spike and pressure bypass so that it doesn't yank the wheel out of your hand. And if you have your hands gripped, a lot of times the crossbars on your steering wheel would catch your thumb and break them. So that was a development out of necessity.
The shock accumulators, we're talking, there's several different types of shocks that you'll see out there. the gas shocks, coilover shocks, air springs. There's all kinds of different ones, but we're talking about a shock accumulator that holds that the nitrogen in it from the shock. There it is right there with the arrow pointing to it. We pay attention to the direction that they're mounted. We don't want them mounted towards the crowd or crossways where it's aiming. So if the cap comes off, it's a disastrous situation. There's been a few instances where caps have blown off, and now we shield them for that reason. But it's unbelievable how far some of those caps have gone. One went through the roof of an arena and went clear out into the parking lot. There's been reports of them going over grandstands, clear over the top. There's been reports of them going clear from the infield out to the outside of a racetrack and out into spectator areas where people are just walking around, with no idea that not watching the race, no idea what's going on with the races, and here comes flying parts at them. So it's extremely important that these accumulators be, first of all, mounted correctly and in the right direction and shielded properly, because they see unbelievable pressures that as the truck lands. And there's been also situations where mounts, you have to watch how they're attached, and the mounting pieces that attach them to the main shock body. There's been situations where tires or other moving parts have hit the brackets and opened the top of the shock like a can opener and just ripped it right open and sent the pieces on their way. So you can see there's several different ways. In the early days of these, some people, of course, we didn't know. People mounted them with the accumulators, excuse me, aiming right out and thought that was okay. We didn't realize it was potentially a problem until we saw that it happened. So we have to make sure that those accumulators are either going up or down, but not straight out at the people.
Let me add a little bit there. As we went through these pictures, this is a question that has been raised in the past. There are different types of shocks, and without going into too much detail, some shocks, like what we would consider monster truck specific shocks today, are displacement shocks. They achieve their spring rate through the displaced oil. The oil that the shock shafts displace goes into the accumulator, and inside the accumulator is a puck that separates the oil from the nitrogen, and that pressure in the nitrogen chamber is what suspends the truck. That's different than like a conventional shock where there's only a small amount of displacement that takes place, so that the pressure in the accumulator is more linear. It doesn't change significantly through the stroke. And then you have coilovers where the weight is being suspended by the springs. Although the pressure differentials between those are quite different, for the sake of simplicity, because not everybody is going to be thoroughly versed in the different types of shock technology, our position is that if the shock has an accumulator, it must have a cap guard, period, regardless of what type of shock it is, because sometimes it can be deceiving. Like an air spring and a conventional shock look almost identical. Like, for example, that is a coilover and a bypass shock. Notice the accumulators look exactly the same. Those two function effectively the same way. Here you have a large 4.0 bypass and an air spring, but the air spring is indistinguishable from a normal shock. It has an accumulator on it and everything. It's the actual piston inside that's the difference. So again, to not have to ask questions to the owner of the vehicle of what type of shock it is, it's just easier for us to just say, you know what, if it has if it has an accumulator, it must have a guard, period. Also, the way the accumulators are mounted is really critical. They are heavy. We've seen instances where tires have gotten into them and they get ripped off and slung. This is an example. The accumulator is missing there. Tires got into it. It didn't have brackets holding it on. It was just secured by the valve. Not a good idea. It's fine when the truck is sitting still, but when a tire gets into it, it's gonna peel things off. And then here's a couple of examples of what we're talking about, that why it's so important that we have these cap guards. This is a little hard to see, but just look carefully at what's going on here. There'll be a slow motion here after this. That's right. Yeah. See that? It's a little hard to see, but what you saw there was a cap blowing off, ricocheting off the ground. It's a little more extreme example. Watch as the truck hits the ramp. Watch the rear shocks. What happened there is it blew the cap off. Here, when it landed, that thing, if you can see the little arrow right there, that is the puck out of the accumulator and coming out as it hit the ground. That cap went out of the stadium, out over the stands and out on the field on the other side. That is why these guards are critical. If there's any, I just noticed a comment about that the video might be glitching. If that happens, let me know so I can back up and show it again. So you see this guard that's covering the accumulator cap there. And there are various styles, depending on the chassis style and everything. Some work better, different shocks, because some shocks have top accumulators, some have low, bottom mount accumulators, some have remote hose remotes. There's different styles, so they require different types of guards.
But something that'll hold that cap on if the cap tries to blow off is what we're looking for.
Yeah, they're like, these are using stainless steel hose clamps. Needs to be something rather substantial to at least deflect the cap where it can't just shoot out. And that's another reason why it's pretty critical that the accumulators not be mounted with the caps pointed outward toward the stands. There are cases where it's virtually unavoidable, and in those cases, the guards need to be really substantial. Notice this is a reverse mount accumulator, so the cap guard style is quite a bit different. There are different variations also for serviceability. These things tend to be a little bit of a pain for people to have to actually maintain the shocks, but it's just one of those things we have to live with for the safety aspect. This is a little bit smaller detail, but something to consider, something that we want people to watch out for when they're doing inspections is some shocks will use clamps to hold the accumulator on that use a single bolt in the center instead of two bolts. Well, the problem with a single bolt clamp like that is that the two pieces can rotate. And what happens is, in this particular case, this was overkill evolution. That, as you can see, the tire got into the clamp. You see how it rotates that misalignment acts as a bottle cap opener. It peeled the cap right off. If you notice, the threads are stripped. It peeled the cap right off because the clamp was mounted right next to the cap. We want, I think it's 2 inches between the guard or between the cap. If it's a single bolt clamp, we need to have at least 2 inches between the clamp and the cap, just to make sure that doesn't happen. It's better to not have single bolt clamps, but if they do, that's just the way to get around to where that can't happen.
We also, just a word of advice here. There's some shock interchangeability or compatibility that's just fine using different manufacturers' parts on different shocks. There's some that have been fine, but we also had found some instances where certain caps, even though they were the same thread pitch, supposedly, one manufacturer and another manufacturer, even though they were the same, weren't compatible. So maybe a brand Y cap on a brand X shock, and it looked like it screwed on there, but it didn't screw on adequately or correctly, and that caused a blow off problems. So in a couple of instances. So, and there's other times when you use a brand Z clamp on a brand X shock and it works just fine. It's just, there's not a rule. There's not of it's got to be a certain type of parts. I just want everybody to be aware that, there is a compatibility problem there in some instances, and you got to be aware of that and make sure that owners and stuff are aware of it too, that you can have a potential problem there.
As a little bit of trivia, but I find it interesting. Some of you might have read this before, that these shocks, our displacement shocks that we consider to be monster truck specific shocks, were actually developed in the early 80s by Bob Giese. And Mike Waters has an original Giese shock in his shop. And one day I went and grabbed it off the shelf and took one of our spare shocks off Evo, and that 1980s cap screwed perfectly right onto this brand new shock. So you can see that basically we took that Giese design, and it's just been duplicated over and over by multiple companies through today, but the basic design is still consistent down to the thread pitch.
All right, in the fuel cell, we're talking about in a lot of instances they're plastic tank like this one. In some cases they're an aluminum tank. There's different places where they're mounted. We want to make sure they're mounted within the frame rails, and somewhat protected even in the event of a crash. And maybe if things get mashed in on top of it, they don't rupture the tank, or wherever valves are on the bottom, that they don't get torn out accidentally of the tank, maybe with a bar or something that breaks off or breaks loose, or somehow hits these fittings and knocks them off. Because in a lot of instances, these tanks are sitting right above a brake and it dumps the fuel out on the brake, and then we know what's going to happen. What's going to happen there. Another thing, there seems to have been a lot of instances of caps, specifically these types of caps. Of course, there's non-vented caps and vented caps. You got to have some kind of vent deal on the fuel cell for it to work right. We don't want this vented cap though. We want a different vent with a rollover valve, because if this thing gets upside down, it's going to leak. Caps are getting left off a lot more often now, and in some instances it's just an accident, somebody left it off, and in other instances we're starting to find that caps wear out, and not only the cap wears out, but the jaws, if you will, of the flange that's on the tank, we're seeing examples of those wearing out. And the guy puts the cap on and he swears he's got it on there, but you turn it a little bit more and it pops right off. And there's been instances where caps have come off even though somebody refueled the truck and did put the cap back on. So my advice, if you're inspecting a truck, is to turn that thing a little bit, tug on it, and make sure that it's that it's good and sealed, because even guys are putting 2 and 3 gaskets on them to try to get them to seal now, and make sure that they're sealing good. And look for this rollover tip over valve. If the thing's just got a vent, an open vent, well, once it's upside down, that's just a highway right to the to dumping the fuel right out. So a lot of times you'll see a coil, maybe a hose coiled up into a curly Q with a special fitting that it's attached to on the tank, and that's really essentially nothing more than a marble inside of a little holder, so that if it tips over, that marble, gravity causes it to pop down and block off the fuel. So that's a much more sophisticated one, that one with the white hat there, but that looked pretty cool. Now here you got a fitting, and you notice that there's a aluminum tread plate there covering the bottom of the tank, keeping the tank so it doesn't get pierced from the bottom. The fitting's coming out of the middle. Fitting's pretty well protected. There is examples of the fitting getting hit by in one case, the 4-link bar took the fitting off, ripped it right off the bottom of the tank, and dumped 20 gallons of alcohol right down on the brakes. So you gotta watch where those are mounted, because of course everybody wants them mounted in the best places for performance. They want to be able, they don't want to starve the thing when it's running down the track, so they're going to put the thing where they feel is the best place for it. But make sure it's in a good place. It's not going to get hit and knocked off. And also, it doesn't hurt to inspect the condition of the fitting. And a lot of, fuel tanks don't get changed. I mean, hell, we got fuel tanks that are, I don't know, I'll bet they're 15 years old or older, maybe even older than that. And they never get changed. And a lot of them plastic ones, they're plastic in the sun. You know what happens to them. And so it doesn't hurt to take an extra look if you're inspecting a truck, or if it's your truck. Just take a look at your fittings there and make sure they're good and sealed up good. Those white plastic washers do a pretty good job, but every once in a while, they'll start to leak a little bit, and obviously nobody can stand any kind of a fuel leak. Four link bars have a pretty big job to do. They hold a lot of weight. They hold a lot of load. They go they when a truck, especially standing straight up and down on one end or the other, you can imagine the loads and stuff that are on those four-link bars and the heim joints that connect them to the chassis. When they, in a catastrophic deal like this, they obviously there's been some significant failure here. But these four-link bars, we require the specific materials that they need to be made out of. We've got minimums that they need to be made out of, because we've learned over the years, as I said at the meeting opening, we got a collective amount of experience, and we've learned what works and what, more importantly, doesn't. And to save somebody the costs and the trouble of early four-link bar failure, especially on a new build or somebody that's new to the sport and builds something that doesn't make it heavy enough, they're going to spend a lot of money when they make one jump, when they find out their four-link bars aren't heavy enough, because there goes drive shafts, pinions, shocks. The list goes on and on. It's going to tear up a hell of a lot of stuff. So, like in this example, this guy's here, he's ruined his pinions tore up, his loops are tore up, his four-link bars are tore up, his drive shaft's broke. He's going to have to call Mark tomorrow to get a drive shaft made. He's got a lot of problems going on here. So that's why we specify these four-link bars minimum, the minimum standards, and they're in the rule book of what they need to be.
Yeah,
So,
that illustrates. I know that some people have questioned, like, what does four-link material have to do with safety? And it's not the four-link bars per se. It's the downstream componentry. When a four-link bar fails, it can cause a lot of other damage, that drivetrain stuff, drive lines and stuff that can either make their way into the cab, or sometimes they'll get folded underneath. They can puncture stuff under the truck, or, worst case scenario, they can get slung away from the truck. And, in as we get into the driveline stuff, we have more examples of that. But a lot of times the failures, the driveline failures start at a suspension component.
four-link bar. Yep.
Yeah. Yeah, and I've got a good example of that coming up. The rod end material is also very critical to this. And we have specifications for rod ends as well. And again, people, what difference does that make? What if I want to build something that's not normal? Well, again, we have, several decades worth of experience of, kind of assessing what works and what doesn't work. And the last thing we want to see is this next slide. Watch carefully. There'll be a slow motion after this. Note the upper rod ends broke. That drive line slinging around.
And all kinds of stuff comes loose in a hurry.
Yeah, now it's potentially ripping brake lines, steering lines, all sorts of stuff. A lot of downstream damage.
Yeah, four-link bars, boy, when just one of them breaks, it causes it's a monumental catastrophe, or it can be.
See, this one, this bung got pulled right out of the four-link bar. which is the threaded piece that goes into the forning that's welded into the forning bar. And this one, the rod end snapped. And then, so that pulled the driveline apart. So you run the risk of a driveline component escaping, which are, obviously turning at very high RPM. You've got sway bars got pulled apart, brake line, steering, everything went just as a result of a rod end break. This is a 3-inch diameter tapered down forking. This is an attempt to address, this is a good example of how monster trucks tend to bounce back and forth between being overbuilt and underbuilt. This is a 3-inch diameter, what are they, 5/8 wall or something? Or what do you remember what those are, Tim? They're really,
No, I
really
don't.
heavy wall.
I don't.
Yeah,
It's huge.
Yeah, they're more than 3/8 wall. I believe they might be 5/8 wall, that are tapered down, virtually indestructible. Great bars. I mean, as far as that goes. But the problem with that is now you've taken that fuse away, and what ends up happening is instead you rip the tabs right off the chassis. So you just change the failure point. So it's all about balance. We try to find the components that do the best job. It's not always, Tim can attest to this when it comes to drive lines. There were a lot of driveline failures at one point, tubing ripping and stuff, and going to heavier wall. Logically you go, well, if we're ripping the tubing on our drive shafts, we need to go to heavier tubing. Well, going to the heavier tubing made the problem worse because you had so much centrifugal force, the mass, rotating mass, that it was working against the forning or the drive lines and made the problem worse. You had to back that down.
And there's trucks out there that'll even run different different thicknesses of drive shafts front and rear because of links or something like that. But even some trucks that have exactly the same length, and we have customers that'll have drive shafts built out of different thicknesses because they found that certain ones last a heck of a lot longer if they do it a specific way. So it's, as you know, monster trucks are unique, and they can how many times we've all heard, man, nobody breaks those, man, nobody breaks, top fuelers don't even break. Well, when in our world, anything breaks.
I noticed Kevin's asking about fornic bar tethers. We're going to have a little bit of discussion about that a little bit further down as we approach towards the end of this. But that is something I can tell you from personal experience. We've launched a fornic bar out from under the truck because we had a failure, and it was at the front end of the truck, so it got peeled underneath the truck, and that snaps the rear one and actually slung the fornic bar out from under the truck. They generally won't go very far, but it is a concern. And again, in the back, I live by this, principle that if it can happen, it eventually will. And the last thing I want to see is a fornic bar getting peeled off and somehow either getting launched into the cab in some way or into the fuel cell or something else. In other words, we need to try to keep everything contained and as tightly to the chassis as possible. And there are many of these type of components that, we got accused of going crazy, of trying to tether everything at one point. But the truth of the matter is, even if you look at Formula Ones and stuff, they run tethers too, because it is a concern. And there are only so many ways to contain these type of components. We want to keep them away from the crowd, and we definitely want to keep them away from the driver as well.
Yeah, anybody that watched the Indy 500 this year saw a tire come off of an Indy car and went flying up into the stands. Fortunately, it found its way right between two grandstands somehow and hit some lady's car.
Funny
but
how
it
that
didn't.
always seems to happen.
It didn't hit any people. For God only knows what happened there, and how it didn't hit people with 300,000 people there. But it didn't, and they were really lucky, and they know that. And that's an IndyCar tire, and what's our tire times 500, probably. But there are stories of four link bars going 50, 60, 70 feet when they've come loose. So It's a spear, and we don't need that. So that is something that that is going to come up. The firewall and windshield, and there was as trucks began to move to the rear engine configuration, there was a question about what do you mean the firewall? Well, where's the firewall? It's between the engine and the driver. And we need substantial protection there for obvious reasons. If the engine explodes or something goes wrong, we're trying to protect our driver. So that's what we're talking about. And then we have debris protection that we're talking about. When stuff gets thrown from the front tires or even the rear tires, gets thrown towards the driver, mud, rocks, dirt, sand, whatever, grass, weeds, stuff that fly up, and we want to try to protect our driver from getting hit by that debris. So a little bit of a difference there between the firewall and the debris protection. There is all the specs are in the rule book. You can get the rule book at MTRA.us. You can, I think that's our website, isn't it right, Marty?
Yeah.
Yeah.
It's MTRA.us.
Yeah, and you can get the rule book there, and you can see these the minimum specs that
It's also accessible through our Facebook page. We're working on that, and that's probably something we should have talked about at the beginning of this, and we'll probably touch on it again at the end of how we're trying to evolve the organization. This thing was created over 30 years ago, and obviously the industry has changed quite a bit. So we want to try to implement whatever technologies we can to modernize the organization and try to make this information as available as possible or as accessible as possible to everyone. So we'll get into that a little bit more towards the end of this presentation.
Trying to save everybody like I say, there's collectively a lot of experience and a lot of things that we've been through that we try to prevent somebody else from going down the same school of hard knocks, so to speak, and just avoid the problem before you have it. So here's an example of a really good firewall, and some good protection there between the engine and the driver. Here we have a whole bunch of protection between the front engine and the driver. Here's a windshield. We want a windshield to protect the driver for obvious reasons, the same reason you want your windshield in your car going down the highway. The tire debris protection we talked about a little bit. Here's something. I mean, I've seen examples of truck where you could stand by the front axle and look up at the seat, and you could throw a football and hit the driver. I mean, you just can't have that. You can imagine what can go wrong there. And anybody that's in control of anything can't be in control of it when you can't see or when you get hit in the face with something. So any of us that have raced a long time are guilty of running with your face shield up or something, and then some mud or water or something flies up and hits you in the face, and for a moment you're stunned, and you can't have that. So we want a windshield, we want your face shield, and we want tire debris protection.
Yeah, some track officials are really good about that. Sometimes, as many of you know, sometimes when you're in the truck and there's a lot going on, you don't even recognize that you'll have your visor up and stuff. And the good ones will point to you and they'll put your visor down, they'll give you a little reminder.
And if you're ever, if God forbid you've ever been in a fire, you'll be glad you had it down.
Well, just a quick note, in this example here, you notice that the Lexan, and that's important to point out also, that this is Lexan, it's not plexiglass or anything. It's polycarbonate material that's very, very, very durable, very impact resistant. But one thing it's not is it doesn't like to be put in a break like this and bent at extreme angles. Here it's almost a 90-degree bend. It will shatter right at that bend. It doesn't like doing that. So we discourage people from, and we recognize that sometimes some chassis designs make it very difficult to mount these, but that's just, we want to try to avoid that as much as possible. Flat sheets like this work better.
And here's the floor. Excuse me. The floor, it sounds as a no-brainer that you need a substantial floor. from those of us that come from the mud racing community, that lighter and lighter and lighter and quick accessibility. We used to have a thin piece of aluminum wire tied in and called it the floor, so to speak. You get a guy that somewhat robust girth gets in there. He's got to have a substantial floor anyway. But protection of boards coming up. There you can see a board that flew up underneath the truck from something debris on the track that they were crushing, whatever it was. They smashed something. Board come loose, went through the floor. It comes through the floor, and there's the driver's seat. That can cause a lot of damage to a driver if it gets up through the seat and hits the driver. Obviously, you can think of all the bad things that can happen there. So you got to have a substantial floor. And with all of the transmissions and drivetrain, the couplers and all that stuff that's underneath, right underneath you, really, really got to have a good floor there. Again, the specs are in the book. The seat, probably one of the most recent huge changes in the sport. Everybody's gone to the really nice NASCAR style seats, much safer than what we just didn't know what we didn't know. We thought the off-road desert racing seats were the answer. I mean, before that, we had van seats or, seats out of a pickup truck or whatever we could find, something that was cool, that just we put it in there, and then we were at the races with a chain and a tractor trying to pull the seat back up straight and stuff because we'd bend them, and then we went to these off-road seats. Man, that's the answer. And then somebody tried one of these, and we thought, well, this is suicide. This guy's going to break his back. How are you going to, until somebody made a run and then realized, well, I won't even do a car crash at a dealership without my seat, because you fit into this containment style seat. You fit into this seat and you let the truck do the work, not your body. These seats are specifically designed for racing and for certain size racers, drivers. There's a handful of different brands. Someone told me that some teams are even beginning to manufacture their own. These seats are in NASCAR. They're made out of carbon fiber. In some cases, most of the monster truck ones are made of aluminum. They've done away with I don't know how many times we saw broken chassis or seat chassis or seat frame that we didn't even know was broken until somebody maybe went to take the seat out or changed seat belts or something, and then realized the seat was broken, and they were just one tube away from a stab in the neck, or we got really lucky that nobody got hurt from broken seats. These seats take all that away. Giant headrests really hold your head, hold your back, hold your rib cage a lot better, a lot more securely. And then the driver can drive the thing as hard as he wants to go, or he or she wants to go, when they're held in place. Because again, just like if you get hit in the face, you can't see, and you can't drive fast when you can't see. Well, you sure can't drive fast when you're not behind the wheel and you're moving all over the place. So, got to have one of these seats, and it's got to be securely mounted to the frame. Make sure that it's mounted correctly, because the best seat in the world isn't worth a damn if it's just thrown in there.
Yeah, there'll be some examples here in a minute, but just to give a little bit of historical information on how these seats came about is, in the 90s, in the early 90s, we started evolving into, it was a brand called Beard suspension seats, because they were very popular in off-road racing. And the idea of a suspension seat made a lot of sense when we had trucks that didn't have the greatest suspension. That was, we were at that transitional point where trucks are starting to get more travel. We're getting into that, going from leaf springs, and now we're into trucks with, 18 inches of travel and all. But I'll give you from my own personal experience with a suspension seat, you'd strap yourself in the truck very securely with your harness and all, and you'd have your crew guy, help tighten your belts. He'd be in there locked in where felt like you couldn't move at all, and you think you're very secure, and then when you'd go out and you'd take a hit, and in some cases you'd have occasions where guys would bust their nose, they hit their face on the steering wheel, and you're like, how could this happen? Where that was as tight as could be. Well, eventually we figured out that what you were submarining in the seat. In other words, when you're tight in the seat when you're sitting there, but as you compress that seat, those belts are now loose, and allows you to move around. You're going to see a good example of that in just a second. that movement allowed you to, it happened so quick, you could hit yourself and then be back tight again. And you're like, you know, it was like you got sucker punched. So through other types of technological development, they discovered this higher dual meter foam that feels like plywood. You sit in the truck and you go, this thing is too hard. I'm going to break my back. Well, that's your body at 1G. But when you're taking a, you know, 5, as much as I think we've been tested at over, you know, impacts over 20 Gs, that seat is all of a sudden really soft when you're 20 times your own weight. So they've made all the difference in the world. And just to give you an idea, you know, obviously they require, you know, they were required a little bit of changes in the chassis design. They're not real easy to fit into some of the older chassis because the seats are pretty big and they're, you know, they're bulky to get in there. But they've made a world of difference in terms of the capabilities of the truck, because the driver can do things they couldn't do before. The drivers just got beat up too much. And this will show you what it used to be like in the monster truck.
And you can see the seat moving around, and not only is he moving around, but hands fly off the steering wheel.
Neck hurts just watching it.
The 8-point cage for older builds, there's some really good diagrams that have been compiled over the years in the rule book that give you a really good idea of you know, what we're looking for, the bars that we count and the ones that we don't. But you can see you know, a good example. And as the trucks, the more recent trucks are built, the standards have increased. Of course, the what the truck's going to do is a lot more elaborate now than what they were doing. Guys are switching to where 125 tubing was the norm before. Now it's 156 or 188 or even heavier in some cases. You know, the trucks, the old, I'm trying to get her down to 8,000 pounds and stuff. Now you hear people, shoot, we're over 11,000, you know, or we're over 11.5, we're 12,000 pounds. That truck weighs 13. Now it's going the other way. But I think people are getting, you know, they don't want to work on them. They want the thing to hold up. And so they build them heavier. So there's not only more bars, but the bars are heavier. But all the minimum specs for all of the roll cages and all the different configurations from the earlier grandfather trucks to the modern day one that's built this week. All of those specs, you'll find them all in the rule book.
This is an example. You know, it was around in the 90s, by the late 80s, early 90s, you know, around the time of, you know, Taurus 3 and Bigfoot 8 and all this, when the 8-point cages started becoming more common. And at the time that they seemed, you know, adequate, because we were modeling our designs off of other sports where, you know, certain things look like they work well for them, so logically they should work for us, but that's not always the case. Monster trucks were very unique in terms of their performance, and of course the weight had a factor, but some of you might remember this kind of stuff that was going on back then. Keep in mind, that was probably a 9,000 pound truck. So you can imagine what would have happened to that cage if that truck had weighed 12, like 13, like a lot of the current trucks. That cage would have been flat. Another example.
This is one of the trucks that finished so well last season, and really a lot of people were looking for great things this year, but that was not the case to be. Truck high side, he's on the throttle. A picture's worth 1,000 words.
That picture's worth 1,000 words. 8,700 pounds, but doesn't do a lot of, at speed. That tubing was nowhere near strong enough, not enough tubing there.
The X brace on the back of the cab, different. It's evolved too to protect, to keep the cage straight in the effect of or in the event of a barrel roll type deal. Helps hold the bars up. It's behind the driver. There's been some evolution of this too. It's gotten more and more and more from a simple X. It's gotten into a much more substantial structure, as you can see here. Essentially, where we're going now with today's stuff is you essentially have a funny car style cage around the driver, and then an older pickup style cage inside the rest of the cab. So you're really protecting the driver, but also attempting to hold up the rest of the truck and protect the rest of the truck, keep it structurally sound in the event of a crash. So this roll cage construction, as you can see, this went from a simple X to look at this U-shaped structure here, and all of these different bars that are in place to help keep from mashing the cab or the cage down and smashing the driver, because he's held in this containment seat now, so we can't let that cage come down and smash the driver. We also don't want it coming down and releasing the belts. The belts are mounted to that, and if all this stuff begins to move, then the belts begin to come loose, and then we're back into that situation where the seat belts aren't tight, and now that opens up another can of worms, and we've got more potential damage. So
one thing I'll point out, the reason that unit is built that way is it's designed to move as one piece, to where if the cage was to get distorted or collapse at all, it comes down as one piece. It's bringing the belts down with it, and the seat, so it doesn't catch the driver, sticking out through the roof or anything like that. It's trying to keep that whole top of the cage as one unit and shift that failure point down some.
Yeah, remember the seat's attached to this too.
Yeah, and another thing that's very important in all is the unpredictability of the direction of the impacts are coming. A lot of times we tend to think in three dimensions. We think of things either horizontal or vertical, and ours we rarely think of things that are diagonal or rearward. You think, well, how am I going to get an impact at the back of the cab? Well, it happens. It just depends on how the truck tumbles. It's a good example of that. Yeah. It actually landed on the back corner of the cab.
12-point roll cage, again, as things have evolved, more structure, more bars, minimum thicknesses increasing in areas where beneath the bars in the main frame, out the outriggers and all of that, to where they can take the more substantial loads that we see from failures of trucks landing directly on the cab from way upside down, from backflips going wrong, and these types of things like that. Man, it just puts unbelievable loads on the frame and on the cage, and trying to keep people from getting hurt.
One thing I'll point out, part of the reason that we are requiring this heavier wall at this point is that we started seeing failures where, as we beef the cages, we're adding more bars and everything to the top sections up here. What we're finding is that as you make this more rigid, you're moving that fuse point down, and what was happening is you're starting to collapse where that tubing meets the main rails. Started to sandwich that bar, and that's a really hard thing to repair as well. So we needed to carry that increased structural integrity all the way through, not just in one area. The other thing are these diagonal support tubes out to the outrigger. These outriggers where the cage, a lot of like the A pillar of the cage comes down. A lot of times in older trucks, you would see those things unsupported, and you're like, you're building a house on stilts. There's nothing there to keep those outriggers from collapsing. You need, you always have to think of things like a diamond where it's the force is continuous all the way around, where it's not just dead ending into some spot.
And more modern day trucks, the trucks that are still using truck bodies, pickup truck bodies, more modern street trucks have more laid back windshields and more aerodynamic and less straight up and down. They're more aerodynamic, they're more laid back, and more likely to they're half on their way to collapsing without that bar already. It's much easier to start to push that. You can imagine putting a load in the corner there and a significant point load, and it's easier to bend that bar when it's already started on its way down, if you know what I'm trying to say here.
Yeah, so we have a maximum angle that we allow for the A pillars, and then we have, of course, the diagonal struts that support those corners as well. You'll see some examples of why that's important in just a second. And then this is another example of that unpredictability of the direction of impact. Very scary moment. But fortunately, good design. The thing took the landing really well. No, actually no damage. You can see there how there's a cage, effectively like a cage within a cage. You see, we've got additional uprights within the outer cage. There you can see that. You see how there's vertical here outside of the, and this is the angle Tim was referring to here, that you don't want such an extreme angle where that thing is laid way back because it's got no strength that way. And then these corner pieces, these corner supports, we're trying to support in every direction, again, because you don't know what direction the impact is going to come from. A vertical might seem strong if you're landing on the roof, but if the impact is diagonal, it'll just push it right over. So we got to take every contingency into account. Some cage designs or some body styles require different alternate cage designs. In this case, we've got a truck design that has functional doors. The window, it doesn't work to get in and out of the windows very easily. So it has functional doors. So they had to accommodate that by making changes to the main cage. But here's the areas where I was talking about that we're beefing up the wall thicknesses to keep the other tubes from compressing those down. It's like 3 times more tubing in a chassis today than there was 20 years ago.
Yep. And it's heavier tubing.
Yeah. Here's an example of what I'm talking about, how the impacts, and this is, keep in mind, this is not a high-speed crash, but watch the upper cab corner, and there'll be a slow motion after this. Watch the upper cab corner. See that deflection? After RJ saw that, he added vertical tubes going to those corners. This tube right here. Again, because this is strong vertically, but not diagonally. Needed that extra piece there to be able to take impact in that direction. A lot of tubing, a lot of welds. This is that cage that I was talking about with the functional doors that required a redesign as opposed to what we would normally do on a regular conventional pickup chassis. As some of you know, that was a career-ending impact right there. Were you there, Tim? I don't remember if you were there. It was very scary. We were sitting back there. We knew something bad had happened, and you know, you don't want to be in a situation like that. As you can see, you know, there's certain parts of the cage that held up very well, and other parts that were not quite as well supported, and those were the points that took the brunt of the hit. That crossbar in front of the seat was resting on his helmet. Sometimes those things don't look like spectacular high-speed crashes, but those instantaneous stops do a lot of damage. They transfer a lot of force to the driver and a lot of force to the chassis. So you can see it did that it totaled that chassis.
You can see the broken tubing.
This is something I just because when I was going through the pictures, it was something that I wanted to point out. A couple of issues that you don't want to. A minute ago, I was talking about how you want to make sure that force is continued, that it doesn't dead end somewhere. The last thing you ever want to see is this: a tube ending on another tube like that. That will just flatten out or punch right. It's like having a punch. It'll impact on this tube here would have impact will punch right through this. As you can see there, how it crinkled that. You don't want to see this needed to have another support tube on the back side of that. Right, like right here. Here's another area that you've got a main part of the main chassis that is unsupported beneath these tubes. It's support over here. What that's doing is it's creating a shear point that will snap right. That thing will break right there. And then this is where I was talking about the Nerf bars, where the cage comes down onto a Nerf bar, but it's unsupported underneath here. These aren't real long. There's not quite as much leverage, but it's still hanging off the edge. And what happens when that is, as you see here, that's what happened here. You see it ripped right. Just what all that corner did is it just took the Nerf bar right off. It took the edge of the end of the Nerf bar off because it was not supported below.
Mm.
Those are the worst kind of hits. You don't want to see things like that. That took quite a hit and held up pretty well. It actually flattened the tube before the cage failed.
And sometimes, landing on rocks or obstacles or debris on the track, whatever, things like that can cause damage to the tubes. And there are specific repair procedures and requirements on repairs.
Yeah, you don't want to go through that either. On top of that, repairs like that take out half the chassis.
Yeah, pretty significant repair.
This is old school. There are some steel body trucks out there still. So we had to have some accommodation for them in the rules. And they're pretty simple. These are generally straight frame trucks. So they have very basic cages. These are non-competition vehicles.
They taught us a lot in the early days. These trucks did.
How not to do things.
Yeah. Nobody imagined failures like that. Never a good thing when two racing vehicles get together. Um, Certainly not when they're, these giants here.
At the back of the cage, that rear tire smacked right into the back of the cage right behind Chucky's head and flattened those tubes out. And fortunately, that truck actually had a double main hoop and still flattened them. So he's good thing because he was a left-hand drive.
Yeah, so those sidebars are particularly important when trucks get together.
Yeah, the last thing we want in cases like this is for something to get into the cab, into the driver. So we've got these crossbars. Now, one thing doing these crossbars, it makes it difficult to get the seats in and out and some of the components. So we do allow for these couplers, as you see there. That's actually a coupler right there. You pull this bolt out, and those pieces lock together. There's one at each end of that tube. It allows for removal of that tube to get the seat in through the side, and then replacement. Those couplers work very well. And they're strong.
And as I was saying, if obviously it's not if, but when a cage is going to need to be repaired. There are strict guidelines, requirements, I should say, for repair. Using plug welds and tube sleeves slid inside to create a repair that's as strong as what you had to start with, or in some cases stronger. And this could be from crashes or even from broken bars, things that need to be chopped out and welded back in, or like I was saying, maybe a bar didn't collapse, but it got smashed. It landed on a rock or something, and it compressed down, and now we got to change that bar. So don't have to junk the whole truck. We can repair it. Just have to repair it correctly. All these guidelines again in the book, MTRA.us.
This illustrates why it's important to do those plug welds, as you see here, that we drill a hole and then do those plug welds rather than just butt welding that tube, because if not, they can pull apart like that.
Split ring wheels, excuse me, not allowed in racing. Now there's a difference between the two-piece racing wheel and the split ring wheel, like we're looking at here. The old agricultural wheels, you can see the arrow pointing to that split cast ring. They used to have an O-ring in there, and they would slide the barrel of the wheel in the tire and then snap this ring over the outside of it. There was an O-ring to seal it, and you inflate the tire, and it was an easy way to mount the tire. The problem is it was really, really dangerous. And for a while, MTRA allowed them like this, where we had a bolt-on guard to hold the retaining ring in place. Then we required them for a while the ring had to be on the inside of the wheel, so that if it came off, it blew to the inside instead of out towards the crowd. But bottom line is it's just no longer allowed. It's dangerous. And even the DOT is getting rid of split ring wheels and semis and stuff. They just don't make them anymore like that. Today's modern two-piece wheels that are bolted together with 40 or something like that, 5/16 or 3/8 bolts, whatever they are. There's a whole bunch of them. That's a different deal than what we're seeing here. So we're not saying that those wheels are illegal. We're saying that these wheels are not allowed.
Yeah, there were fatalities as a result of split rings.
Yeah, people inflating them and having wheels come apart, and it was just a disaster. We have the wheel restraint system. We talked earlier about wheels flying off. One of the biggest problems that we face, of course, is the wheels coming off. Obviously when it gets loose, you got 800-900 pounds, whatever it is, of tire and wheel with its own mind, going wherever it wants to go.
See, a lot of times, and this is going to spill over in other conversations. This is probably the single biggest challenge that we're facing right now is wheels, trying to restrain these things, and this has implications on event safety, placement of spectators and all. Dodged a lot of bullets. Figure this out. Look at that. It happens so fast, people tend to think, oh, I could, get out of here. It happens really fast. Your brain doesn't react as quick as you think it does sometimes, especially when, in the case of a spectator that is not expecting for something like that. They've never seen it. They're not as familiar with this type of failures and stuff. We've got to come up with a better way. This failure we saw right there was actually a cable tether, wheel restraint system. And this is a good example of why we don't allow those anymore. They were not foolproof enough. There you see the cable restraint inside the wheel there. You see how it's wrapped around. This is a cable that's snatched.
We thought that was the answer at the time, but we quickly realized that it wasn't.
Same cable tether.
Oh shit! Move out of the fucking way! Oh my god!
And once that's off the track, like Marty said, now you got spectators or people walking around, maybe at the fair or wherever this might be, that they certainly don't expect this thing to be coming at them. They're not paying any attention.
That went out onto the midway. Spindle failure, among the most common cause of this. You also see a lot that will, they strip the bolts of the spindle bolts out of the knuckle. So we've, developed these mechanical wheel restraint systems. Dan Patrick came up with this system that uses a plate or two plates that capture a ring that's attached to the hub to keep that attached to the knuckle. They're very effective. But the design needs to be robust. There are a couple of different variations on this theme that have been used. And slowly they've gotten better. They do a pretty good job of keeping the wheels close to the vehicle. There's probably still room for some improvement. We're still seeing associated failures.
And we've seen failures that, upstream, so to speak, that the restraint, inbound of the restraint, that it's not going to, the restraint didn't fail, but the wheel still got away when a flange come off or something.
This is a slight variation on the one you saw before. Let me back up just to show you the difference. You see here, you have two plates that are attached to the knuckle, to this bracket on the knuckle, or these brackets on the knuckle. And the rotor, this disc, is attached to the hub. This other variation is the opposite. The brackets attached to the knuckle have a single plate, and the rotors attached to the hub are dual plate. So we've seen them both ways. This one is only using one capture plate, which in theory should work, but the concern here is these upper and lower brackets only capturing two bolts. There's a lot of leverage. I mean, keep in mind when the truck lands, and that if the spindle breaks or the threads pull, all of the force of that truck is being carried by that upper bracket. So they will invariably fold or rip right off. And so we've learned that these restraints needed to be a lot heavier than we originally anticipated. They've gotten beefier as we go along. Here you see a good example of one that did its job. A lot of times they'll be junk after this thing, but at least they kept the wheel in place.
And there's been, the truck drove back to the pits with it busted, and the wheel stayed on the truck. So, did its job.
There you can see the brackets are destroyed, but they kept the wheel attached to the vehicle. And then when the wheel escapes, that can create other problems. You see here. Elevated floor, but look at where the announcers were. Right, that the K barrier is the only thing that kept it from going straight in at them. Again, the restraints just ripped apart in that case right there. Also, not only is there the danger of the wheel, there also can do building damage and all sorts of things we don't want as well.
Yeah, we don't need any more buildings saying we can't race there.
Yeah. Numerous examples of this. Like I said, this is one of the biggest areas of concern for us. You know, which raises the point, you know, this has been an evolutionary process. This didn't happen overnight, and this has taken decades to refine these rules and come up with, you know, effective solutions to keep spectators safe, keep drivers safe, and all. But we're still learning. I mean, we never finish. But we've reached a point where the failures on the trucks are pretty limited, and a lot more are starting to be, you know, involve the facilities that the trucks perform in rather than the trucks themselves. Like, you can have the safest truck in the world and you put it in the wrong environment and it's not particularly safe. And another thing that we have to point out is that a lot of in the overwhelming majority of these cases, this is not anything that anybody did wrong. The drivers didn't do anything wrong. The people that built the truck didn't do anything wrong. It's just what we do is inherently dangerous, and we have to think through these things. And again, with that mentality, if it can happen, it will. So what do we need to do to ensure the safety of all of those people around the trucks? You know, and that includes also, a lot of times, the very commonly neglected people are the crew, the people that actually work around the vehicles. They're the ones that are actually very often exposed to more danger because they're working in areas where trucks are moving and lots of things can happen. They're fueling trucks. And so that's another area that we have to concern ourselves with. Here we're seeing another variation on this failure theme. We've improved the design of the wheel restraints to the point where they do a very good job of keeping the wheel and hub assembly attached to the knuckle. But what happens occasionally is the champagne, which is the trunnion, which is inboard of the knuckle, are failing. And at that point, there is no restraint. The restraint is going with the broken off piece. You see here the champagne snapped off. So the wheel assembly with hub, wheel restraint, knuckle, everything left the vehicle. Now they're heavy. They oftentimes won't travel quite as far, but they still get away, and it's still an area of concern. So when inspectors are doing their inspection, we urge them to make sure and check the champagnes for cracks. There are a lot of areas like that we'll cover, things that are not necessarily in the rules, because I mean, we can't, you don't have a cracked component. I mean, that's fairly obvious, but there are areas where trucks are more prone to develop cracks and different types of things that are related to that we'll get into as we get into other areas of the truck. You see, this is a pretty common failure, the champagne's breaking. There are improved components, as everything, if we find a piece that breaks, we try to develop new pieces. Part of the design of the champagne, particularly on the Clark, is that this bevel area, or this chamfer right here, is very abrupt on the standard Clark champagnes. So the CRDs and some of the aftermarket champagnes have a little bit better rate, a little more bigger radius. So there's a little more material that doesn't create a stress riser.
And better material.
Yeah, and better material on top of that. Mm-hmm. Upsized bolts, and some of them, the flanges are bigger diameter or thicker. we're trying to improve these things. And, I know that maybe the trucks of today don't necessarily look particularly different than those of 10 years ago or, but in reality, they're vastly different. It's in the metallurgy involved and very things you can't see from the stands, just the technology is being refined down to smaller details. Here's a different failure. See, the restraint is still attached to the knuckle, but what happened is the retaining ring detached itself from the hub. Some hubs, there are aftermarket hubs like this is a CRD hub that have the retaining ring cast directly into the knuckle, into the hub. Previously, most of these, we were welding the rings to the hub. You're welding to cast. It's good material, but sometimes the welds don't hold and the things will come loose. This is a preferred method, but beyond that, there are these girdles that attach to the studs. It's an entire piece that has the ring integrated into it, and it's attached. It's also bolted to the brake drum mounting bolts. There's another consideration. Some of these that didn't have continuous rings, we had early on a requirement that it covers 56 degrees of the circumference of the hub to make sure we were capturing enough of that. But as you see here, you see those brackets are only captured, the pieces in red are capturing that ring on the hub, which in theory should hold it. But this is what happens when you don't have those. Notice how without the ring, these are independent pieces. The red pieces are independent. They're not attached to each other. So what happens is when the truck lands, if the spindle breaks or anything, all the load is carried by the upper bracket. Truck on the far lane. Notice the wheel actually accelerated away from the truck because where the brackets bent, it actually spit the rotor out and accelerated the wheel away from it. So it's very important that those upper and lower brackets be tied together with, like this, or a ring. Some guys don't like the idea of a ring because it's more work when they have to change an axle or anything, but safety comes first. We have to ensure that these things can't get away, that being able to maintain the trucks is secondary to that. That's a ZF style planetary, which is a bit different. They're smaller. They're strong, but they're smaller diameter, more compact, not as much room to work with. And we've seen designs like this where that would never hold a wheel. Those little fingers that it's got holding the rotor, it'd be like they're not even there. They've developed a much more robust system that uses a full ring to capture that. That's preferred.
And now we move to the engine, the exhaust. We want the exhaust to point up or back or down, not straight out at the crowd. There's zoomies, there's collected headers. But if something, engine drops a valve or head gasket comes out, something that's inside wants out and makes its way out, it'll find its way out. And I've seen collected headers turned and pointed right towards the crowd. Here's a situation here where, if something comes out of the header, it's going right into stands.
Yeah.
And not only is it flying at a pretty good rate, but it's also hot. So we got some problems there. So we need to keep that aimed straight up or straight down, or slightly back. I think we allow 10 degrees or something. We want, again, the idea is parts getting out of there don't come flying into the crowd. And there was, in turbocharged situations, there was some situations with tractor pullers. A lady was killed earlier this year when a turbo wheel came apart, came out of the exhaust, and hit a lady. So there's a lot. We got to watch stuff coming out of there. Make sure the exhaust is aimed in the right direction. Injection and carburetor return springs. Yeah, this is a horrible situation here.
3 people have been killed in the Netherlands during a stunt show, including a child. A giant pickup truck span out of control in the Dutch city of Haaksbergen. The local mayor said at least a dozen people were injured, 5 of them seriously. One of the victims said, they need to find a bigger location, somewhere outside the town centre where there's more space. It could have driven straight into the supermarket or the bank. The so-called monster truck was driving over a row of cars when it appeared to lose control. It ploughed over safety barriers into the crowd. Local helicopter ambulances flew in from around the region, including from neighbouring Germany. One of the organisers speculated that the truck's accelerator became stuck or its brakes failed.
So there's the spring, and it's hooked to a good mount. I've seen these clipped to a valve cover. I've seen them wrapped a wire tied around hoses and stuff. And we want to make sure that those return springs are, first of all, robust enough to pull the throttle back. We want a toe strap. We'll get to that in a second, to make sure that the driver can pull that back if something happens on the cable. But that return spring should snap the butterflies right back closed. We want one on each side, and we want a good mount. There's an example of one on the gas pedal.
Yeah, that has to be independent. That does not count.
Perfectly fine, you're right, but doesn't count as the ones on the butterflies. Doesn't take much imagination to realize what a stuck throttle can do.
In that case, the pin, you see there's a little wire that holds the pin for the release, to release the air filter there. The little wire got caught on the throttle leakage as it opened and hung it wide open. This is a different type of pin.
In that case, it was a bolt. That bolt that right there backed out and got against that rounded surface of the injector hat and went down around that angle, and then it wouldn't snap back up. And that's because that bolt backed out. In this case, it's got a nut there holding it in. But most instances, when you look at these, that screw, it's like a 1032 screw or something. It's just screwed right into that black aluminum arm, and that's it. There's not a nut to capture it on the other side, and that nut or that screw will start to back out. And for whatever reason, Enderley put them on like that, and so most of them are built like that, where the screw's on that side of the of the injector. And if it gets out, worst case, if it was the other way and it came out, okay, the guy's going to step on the gas and nothing's going to happen. But in this case, it goes down. He's mashed on it with all his adrenaline, with all his force. So he mashed right past the aluminum side, but now it won't come back under its own. You need a spring. The spring just doesn't have enough tension to pull it back.
We've heard of several cases of this happening, of throttle hanging for this reason.
So check your own trucks, and check anytime you're inspecting one. Watch that and make sure that those screws are screwed all the way in.
hear that throttle hung. No audio on this, but you can tell from the brakes. See, his throttle's hung right there. He's trying to stop it as much as he could. And you notice the person standing there at the end as well. That's the positive push-pull cable.
Anybody's tried to push a chain, right? You can't do it. So we want a cable that push-pull cable that operates in both directions. So it's not, imagine a piece of string. You could pull the throttle open with a piece of string, but you can't push it closed. So we got to have we want that cable to be operational in both directions. That's what we mean by push-pull cable.
Yeah, not especially like, let's say, on a steel cab truck or something that might have a standard old style, nowadays they're electronic, but an old style cable throttle, that won't work because it will pull, but it won't push. So, worse, this is an extra level of trying to do something about it. That with that pedal, you can try to pull it up. Well, with a cable, that won't do you any good. It needs to be a push-pull style. This is not a monster truck. That shows you another example of what happens when a throttle hangs.
I got that on video. Oh my gosh.
Terrible example.
Oh my gosh.
Good Lord. The supercharger. 871s, 10% max is what we allow. It's a 16-inch case. There's some modern day Superman versions and some different stuff, but the rotor inside, we required the stock GM rotor angles, not a high helix, the ones that are twisted a little bit to get more air. 10% overdrive refers to the pulleys, the relationship between the top pulley and the bottom pulley. We allow the top pulley to be, or the supercharger to be 10% overdriven, and that's a maximum. You can't change it even if you're in Colorado Springs or Denver air. You can't turn her up to make some more power. You got to leave it at 10%. There's a restraint, a 14.1 restraint that goes on the top of the supercharger to keep it attached to the manifold. SFI specifies what you don't just use a belt or something that you got laying around. It's got to be an SFI approved unit. There's straps that hold it down. The aluminum blower studs that we'll get to in a second help keep there's the aluminum stud. If something goes wrong and there's something wrong inside the engine, cam brakes, valves, whatever, all this pressure, it's got to get out. Well, it's going to break that aluminum stud. The blower will pop off, vent it, the restraints catch it, and we can go fix it in the pits and come back and race tomorrow. Yeah, we got shielding around. You can see those fuel lines going into those gold check valves, screwing into the barrel valve there. Those 3 silver hoses going into those gold check valves. We want to protect in case the belt comes off, the direction, the rotation of the belt. We don't want the belt to take those lines, rip them off, and the pump's still running before the engine dies and start spraying fuel all over the place. So we're going to have a little bit of a guard there to keep that from coming off.
This is what happens when you don't have the aluminum studs.
Yeah. That guy just spent a lot of money. He's lucky nobody got hurt. There you can see a supercharger failure that, of a significant magnitude.
Ingested something, it appears.
Yeah. And we don't require bags like dragsters do, but we don't require that. We haven't had that kind of a failure. This is a pretty rare example of failure here. But we do want to keep those restraints. Fortunately, it's not a big deal with our 8% or our 10% 871s. We haven't had a lot of problems of superchargers blowing off, but let's keep it that way. Deflection shields on the side of the engine, very important, specifically in concrete shows where if something comes out and can get away from the engine, rod comes out or something, blows out and bounce off the concrete, it can go somewhere. So we want we want to keep those deflection shields on the side of the engine. So if something does come out, it hits the shield, knocks it down on the ground, and that's it. It's energy spent, and we just got a situation where we have to fix the engine, but at least there's not parts in the stands.
This is the most common style we see nowadays. So they're bolted right to the engine block itself.
Sometimes they're bolted to the frame. Sometimes they're bolted to the engine mounts, right? Like in this case. Electric fans, excuse me, electric fans and pulleys. We don't allow engine-driven fans. We want only electric fans. That way, they can spin at their prescribed RPM, whatever it is, and they're not spinning it at 8 or 9,000 RPM and coming apart. These pulleys, remember, especially pulleys that are up on the supercharger, they're 10% faster than the engine. So if the engine's at 8,000, they're almost 9,000. They're turning pretty significant RPM. So they got to be pulleys they're billet pulleys or made out of materials that can withstand that. An old cast iron dump truck steering pulley is made to turn at 2,000, 3,000 RPM, not 10,000. So we got to watch those pulleys, what they're made of. Harmonic balancers, same thing. The harmonic balancer on a street car is a two-piece unit. It's a manufacturer makes it real easy to it takes the dampener takes the vibrations out of the crankshaft. It was never meant to have blower pulleys and stuff bolted on it and see these significant RPMs. Here's a failure of the hub on one of them. Oftentimes the two pieces separate, the wheels. So we require an SFI approved balancer if you're using one. And in most cases, you're going to find that the engine just has a crank hub, doesn't even have a balancer. But the transmission and clutch, the transmission blanket, we're looking at the transmission and clutch. We got to have a blanket on certain types of transmissions. In the old days, transmission failures were so common, and it was not uncommon to blow a transmission clear off the motor. In some cases, they would flip upside down. It was horrible. Parts come again through the floor, hit drivers. It's just a horrible, horrible thing. So we required blankets on most transmissions. In this case,
piece went right through the windshield.
Yeah, come through the floor, past the driver, and then went through the windshield. So there's the transmission blanket that's required. Now, of course, most of the trucks today are running a Power Glide style transmission, and they have an SFI approved shielding inside them or an SFI approved case. In this case, you can see the SFI sticker there. We should probably just explain what SFI is a safety organization that most racing organizations and sanctioning bodies belong to. That is an independent organization that tests parts from manufacturers that manufacturers submit. The MTRA is a member of the SFI. We pay our annual membership dues. Monster Jam's a member of the AMA, NASCAR, NHRA, boat racers, Southern California Timing. So everybody's a member of this. Everybody uses these SFI rules. And the SFI tests these things, and they help protect us all from ourselves of getting inferior parts and bolting them on, and then the resulting damage and injuries that result. So that's why you'll see SFI specs throughout our rule book, and we are allowed to use them because we're a member of the association. Those Power Glide transmissions have shielding inside them so that they don't require the blanket, and they still will fail. In this case, you look right below the read word there, you can see the crack. They still can fail. So it's not bulletproof, but there's shielding inside, and as long as it's inside there, SFI tells us that it'll contain the failures. May damage it, but it's going to contain it. And transmission failures continue to be a huge part of our world. I mean, now this is some extreme examples of failures and an attempted repair there, but mostly from the heat. As driver continues with an extensive freestyle run, those things build unbelievable heat, and they see just unreal temperatures, unfathomable temperatures, and then the results are explosions or fires. So let's take every precaution to get the best transmission stuff we can. The flex plate, another part, essentially a saw blade that connects the engine to the transmission. We require that to be an SFI approved flex plate. The ones that come from the manufacturer are so flimsy that they just don't do the job. The SFI approved ones are much thicker. They don't crack around the flange where they bolt to the crankshaft, and they hold the starter gear, if you're using a starter gear, in a much more secure way. Watch in this case, this is a really unfortunate example of a flex plate coming apart.
Yeah, I want to apologize to everybody in advance, but sometimes we have to show things that make people uncomfortable to get the point across, and illustrates why shielding of the flex plate, which is for a while was somewhat neglected. It's gotten better, but this illustrates the importance. The black and gray car, furthest from the camera, is on a dyno. They're running it through, and the guy in the red shirt's observing. Watch the floorboard just behind, or watch the ground like just behind the front wheel of the car as this thing's on the dyno. Flex plate came apart, ricocheted off the floor, and killed him instantly. So you can imagine on a monster truck where it's much more exposed.
And especially in a situation where the truck's upside down. And, the tendency is for a driver to floorboard it, trying to make a spectacular save or whatever. That's why the bottom of that GM Powerglide style transmission is open. And so we have to have adequate shielding there to contain that flex plate. And we have to have first of all, we got a higher quality flex plate than the stock one. And then we're containing it, so we got a double, little bit of double safety there. Here you can see part of the required shielding. Very, very important. The driveline and brakes, billet end yokes.
Another unfortunate video.
This photo shows rescue workers and volunteers trying to help Sebastian Hizzy, a 6-year-old spectator, after he was hit by flying debris at a Monster Jam truck show Friday night. The boy was sitting in the stands with his family when the debris from one of the trucks apparently flew 30 to 50 feet over a safety barrier and struck him.
It was just really sad. The parents, and they had other little kids with them, and everyone was screaming and crying. And
take a look at the sparks from this red truck. Witnesses say the truck came apart as it was doing donuts during a freestyle competition. The little boy's father told a local TV station his son was hit in the head by a piece of metal the size of a frisbee. One other spectator, an adult, was also injured.
I couldn't even sleep last night. It was just horrific.
Some of the spectators thought the response was slow and the show should have been stopped.
I thought that they should have at least stopped it and made everybody stay in their seats until they got him out and then had everybody leave.
The show's promoter, Feld Motorsports of Aurora, Illinois, promised more inspections of trucks in the show and said the one that sent the debris flying would be withdrawn.
We didn't know what the gravity of the situation was until after the show was over. We have to gather all of the information, and we're in the process of doing that now before we make a determination.
The company released a statement expressing its sadness over the fatal accident and said this kind of incident had never happened before in the history of Monster Jam events. Ross Simpson, The Associated Press.
That had a lot of repercussions, obviously, and a lot of things changed as a result of that. That's a position nobody wants to be in, and they went to great lengths to ensure that never happened again. Lots of new technology was implemented. So This is not to in any way to suggest that anybody did anything wrong. Sometimes there are dangers that were not foreseen, but we definitely know that everything was within anyone's power was done to make sure that that didn't happen again. And that's why sometimes we get accused of being overly cautious about some things, but nobody wants to be in a position to have to face a situation like that.
The billet yokes come out of that. Here's one that the brake rotor's mounted to on the differential side. Much stronger pieces. The driveline loops were completely redesigned after that Tacoma accident. We had extensive amounts of research done very quickly, from designs that were submitted, different types of designs, the materials, the welding processes. We personally had some stuff that we had a U.S. Army welding expert take some samples of to see how they were, if we were welding them correctly and making sure the penetration was right and all that stuff, because this was brought into being such an important. It was such an important. There was a huge effort to fix these. I know Feld did some extensive testing with drive shafts and intentionally causing them to fail and videotaping it with a 600 frame camera, and it was huge, the amount of research that went into this. One of the professors from the University of Illinois here that's involved in the safer barrier designs and all that stuff, he was brought in, and we got his expertise on these designs. And bottom line is, this design has been incorporated just about into everybody's rules, and it works. There was pushback initially from people thinking it was being forced upon them, but everybody has agreed that, once they tested these things, they work. I remember personally, we used to go through drive shaft loops weekly. We'd have to weld them back together. They were twisting apart, coming apart. This design allows them to flex. The rotator allows them to move. You don't even address them anymore. You never break them. They withstand drive shafts failures, and you bolt them right back on. So build them like the rules call for, and you won't have the problems. Again, the drive shafts coming apart, our drive shafts see such incredible speeds. Most of the time, people don't even think about the drive shaft speeds that we have with the low gearing and the speeds that the trucks run. The drive shafts just turn hellacious RPM, and they can unwrap like a tube of biscuits. They'll just come right apart. Some of that has to do with the thickness of the material, the different wall thicknesses. And when you repair the drive shaft fails and you repair it in the pits and you're in a hurry, don't just come back out without your loops because you're in a hurry and you got to try to make it to freestyle or whatever. Here's an example of a truck that got back out there without the loops on, and well, they failed in the first place, and that's why they're not on there now, right? Because they didn't put them back on. So the thought that, well, that's not going to happen to me, well, it will.
And we understand,
put your loops back on.
We understand that sometimes, people, spectators will get upset if a truck can't come back out because they can't get it back together, or not, some of the parts are damaged. And for us, it's better for the truck not to run than to run with something that could, of such significance like this. It's critical. In other words, no truck should ever run without loops on it, no matter what, under any circumstances, period.
The U-joint shields, pretty substantial. The designs have been refined over the years. Here you see that piece of tube, the arrows pointing to that piece of tube that the loops are bolted to. That's guarding that U-joint. If the U-joint comes apart, the caps fly out, the yoke breaks, whatever happens there, it's contained. It's not going to get, it's not going to get away. There was, in the early days, caps would fly off, come apart, and fly up into the stands. People get hit with them. That just doesn't happen with that kind of a U-joint protector. The rotator device allows those redesigned loops, like we were talking about, to rotate, to articulate with the truck. the 4-link suspension on today's modern trucks just allows unbelievable articulation with the axles, that one axle or one wheel moves up, the other wheel moves down. They can move at such extreme angles that we have to have some way for this drive shaft loop to be able to compensate and to move with the axle housing. And that's why we need this rotator to allow it to move. There are several different designs. But it says in the rule book of how that has to be. It has, first of all, you have to have a rotator. You have to, if you don't, you're going to have a failure. So you have to have some way for that loop to be able to rotate and move with the axle articulation. So that's what we're requiring. The jack shaft and couplers. The jack shaft is that short shaft that goes between the transmission and the transfer case. In some cases, guys have the transfer case mounted directly to the transmission, the shaft splines right in or whatever, and they don't have a jack shaft. That's fine. We have to have this shielded. We want to have the whatever that some guys are using, like drag racing, funny car or dragster type shafts. Some people use a regular automotive, like a drive shaft, just like the front or rear drive shaft that goes between the transmission and transfer case. Whatever it is, makes no difference. We want it shielded, and shielded substantially. Again, it's right underneath the seat. Very dangerous if that comes apart. And it's seeing some significant speeds too. And when you mash the gas, it's right there. The intermediate shafts, for the rear engine trucks, the transmission goes into the transfer case, comes down, and we got this intermediate shaft tube, a tunnel that we got usually an axle-like shaft instead of a drive shaft that's connecting the transfer case to a carrier bearing, a yoke, and then to the rear drive shaft. So you can see that solid tube there that needs to be inside of. The slip yokes, an important part of the drive shaft. As long as there's enough engagement, we got to have we don't want it to come apart. When it's fully compressed or fully extended.
Yeah. As the suspension moves, because the drive shafts are not the same length as the 4-link bars, the drive shafts change length through the cycle of the suspension. So they have to have a slip joint to allow for that deflection. And they have to be properly sized so that they have adequate spline engagement. They can't bottom out or they'll break, or they can't pull apart, as obviously.
There's usually like a blue nylon-like substance on the splines, and you don't want that sticking out. In this case, we've put a piece of hose on there to keep it from, to keep the drive shaft. If the yoke would break, or slip yoke or something, or the U-joint breaks, the slip yoke tries to slide back and get out of the yoke, or get out of the shields. They put that rubber hose on there to try to keep that from happening.
Right. Without this piece can escape. It can escape the U-joint shield. It can slip out, and then the caps are exposed. So that's what this rubber hose, which is required, is designed to effectively be a spring to keep this extended and inside of the cage. A couple of different styles of slip joints.
Different styles of splines.
The all spline, just because this is important sometimes, you have to recognize the type. These are the standard type. These are the all spline type. The all spline type, you will see splines exposed because of it's the whole shaft. So that's what you're seeing there, is because that spline runs way up here. This is the regular style that you don't want to see. Exposed splines like that.
That's going to come apart, and then the drive shaft's loose. You don't want that either.
Yeah. That's really concerning, because in this case, this truck didn't have a shield where the slip joint is, and the problem with that is that this stub is loose. In other words, it's detached from there. That can actually slip out, and this piece can be ejected. I've seen that happen from personal experience. The stub broke off. That's
went somewhere.
One of the most common, right? That's one of the most common failures on drivelines, is the slip stub will break off the main shaft. That's this piece right here. This one, the weld broke, but a lot of times they'll break right here.
The dual braking system. two completely separate master cylinders, one for the front, one for the rear, operated by the same brake pedal. Not two chambers within one master cylinder, but two completely separate ones.
We
so
want
that
redundancy, right?
Yep.
Redundancy.
If the line breaks off, caliper fails, whatever, we still got some brakes to stop us.
Brakes should have a pretty substantial pad.
Yeah, the stock little pedal that comes with them is pretty much useless. Billet steel rotors, not a cast, something off an F-250 or something that somebody dug out of the junkyard and used for a brake. That was in the old days. Not anymore. We got to have a billet rotor. And it's been brought to my attention about the holes on some of these vented rotors, like this one that has a bunch of holes. There's cases that people have documented and showed me where the holes are drilled too close to the outside, and then they crack right away. But these things, of course, go through tremendous heat cycles, heating and cooling cycles. And so when you're dealing with one of these vented ones with the holes in it, have a good look at that when you're inspecting the truck and see especially if those holes are close to the outside edge of the rotor, there's tendencies for them to split out. So have a good look at that.
With that heat cycle that Tim was referring to, we found that the weak point are actually the bolts. And this is something very critical to the inspection process, because a lot of times the drivers or crews don't catch it. That these bolts, the rotors get red hot and the bolts go right with it. So through that cycle, the bolts lose their annealing and they'll fail. See, like here, this bolt's missing.
And the nylock there isn't going to do any good.
Right.
It gets so hot, it burns the nylon right out of it. So we got to have the stock or the steel. I'm sorry, the steel lock nut, not a nylock.
Yeah, they're called prevailing torque lock nuts. They look like they're squashed. The hole's not round; it's kind of oblong. It's a lock nut without nylon. The nylon will melt out immediately; like they're useless. This is something we saw recently. I hadn't run across. These rotors were actually tapped, so the bolt screwed directly into the rotor itself. Again, through that heat cycle, I don't know that I would trust that. We'd like to see, on top of it being threaded, I think it would be much better to have the prevailing torque nuts on there. You just, a longer bolt that goes all the way through. Sorry, we're having to move along. We're running out of time, so I'm kind of going through this, and we will have follow-ups. The idea is to have follow-ups where we'll be able to delve into each one of these areas in greater detail, and maybe a shorter meeting. So yeah, I'm sure there'll be questions. If anybody has questions, we can address them at the end of this or in a later meeting.
The RII transmitter and receiver, of course, a very important part of our of the development of probably the single most important, one of the single most important things that the MTRA has invented was the remote ignition interrupter. Some way to shut off a truck when a driver was incapacitated. In this case, driver knocked out, hits the end of the stands, and there was a fatality.
8 spectators, including 4 young children, were killed and around 80 other people injured when a monster truck ran out of control and plowed into the crowd at an air show in northern Mexico on Sunday. The accident occurred when the monster truck, with tires measuring 1.5 meters tall, suddenly veered to the right after making a second run over 2 cars during a performance at an air show in Chihuahua. The tragic events that followed were captured on film by several members of the audience. The driver said in a statement that he lost consciousness as the truck bounced violently upon impact with the ground, while several witnesses recalled seeing the driver's helmet knocked off by the impact. An investigation is looking into whether a mechanical fault caused the truck to accelerate uncontrollably. A breath test administered at the site detected alcohol on the driver's breath. Of the dozens injured, 12 people remain in intensive care, with 4 in critical condition. Local authorities are now looking into whether safety regulations had been correctly enforced at the event.
So here's one of the second generation or so of RIIs. Very common still. This is a Birch unit. He has a more updated one now in a metal case, but left, center, and right lanes. Activate the lane lights up in the window. You can see here in this case it's turned on. This is a new system that's being developed. I think it's still being developed. I don't know that it's out yet. That even allows for resetting. The officials can reset and it sends signals back and forth. It's a pretty slick system once they get it designed. Produced, I should say. They've already got it designed. They're just working on getting all the production and stuff from it. But
yes, it is available now.
Okay, good.
This is just to point out that it's important also the way you run the wiring for the RII. If you watch this failed look at the light on the RII right there. See it turn off mid rotation. Cable got damaged and shut the truck off mid rotation. Did a lot of damage to the truck as a result of that. It's another instance where the cables, in a rollover, the fiberglass caught on the RII cables and pulled them out of the box and shut the truck down.
The RII lights, the red and yellow lights up in the windows, red on the right, yellow on the left, to signify that the RII system is functioning, and the RII antenna. In some cases, the radio manufacturers wanted an antenna. In other cases, they don't. But if there is an antenna, it has to be mounted straight up and down. Has to do with a cone of silence or something, the way the RII works or the way radio signals work. The backup alarm, when you put it in reverse, it automatically comes on, not toggle switch or something that you got to turn on when you put it in reverse. We want it to come on automatically with the shifter when they put it in reverse. Aim to the back, something pretty substantial, and a light that flashes, or light that comes on too, so that we know that somebody's in reverse. The in-cab kill switch.
Sometimes in a loud environment, you won't hear the backup alarm, or you'll have multiple trucks running and you don't know which one's moving. So that's what the light is important, because it will catch your attention that something's moving.
And we're back at our in-cab kill switch.
So yesterday we were tuning this thing and the throttle stuck wide open. So it's not something I'm not familiar with. I reached and hit the kill switch and it didn't do shit. So then my next thing was to go to the ignition box, but at that point I had hit a truck in my yard because this thing kind of drifted on me, and the truck had gone on two wheels, and at that point I wasn't strapped in, no helmet, which I've gotten a lot better with that stuff. But so what I want people to take from this is, it is serious shit. It is. I joke about a lot of things and I try to make light of subjects, and I've been scared to death before. Yesterday didn't scare me at all. I was more mad at myself because there's a lot of things I really could have done different that really would have prevented that. And that's 100% on me, and I'm glad I learned it. I'm very glad that John wasn't in this truck, because he would probably be dead. I ended up with 4 broken ribs, a couple staples in my head, a hole in my lung, I don't know, some black eyes, bumps and bruises, and my legs are pretty fucked up, but we'll be alright. And again, this isn't to like brag or boast, I know I'm an OG guy in this industry, and this shit happens to even me. It's just like in a pinch, in a hurry, getting it done. I always try to give informative videos, but I can think of a bunch of better ways I'd rather do a video than this one. Like I said, I reached for every single thing that there was there to shut it off, and it did not. That thing just said, we're going for a ride, let's go. So If there's anything I can tell you guys, it's that. Take time, slow down, be a little safer. Don't die.
Here we have the in-cab controls labeled. Fuel, power need to be labeled so that if someone else is in there, they know they can emergency workers, whatever, they know what to get at if the driver's knocked out.
And the kill switch needs to be a push to kill. Like, it needs to be something that in a split second the driver can just hit it to shut the truck off. It needs to be within reach, even with the driver with his eyes closed, needs to be able to hit that thing and shut it off. I recently saw a couple of trucks using the twist type inside the cab. And in an emergency, that's not ideal. I mean, like the video where the truck shut off mid rotation, the driver shut the truck off, even though the RI died. He shut the truck off in mid rotation quickly. I mean, and it was a split second. A twist type is going to be more cumbersome. The rules don't allow for that. Again, there's a twist type right there.
The in-cab fuel shutoff we touched on a second ago. It can be pull or push. I think, right? We've changed that to allow them to go either way, but we want it labeled. And even with EFI, there's a lot of teams switching to electronic fuel injection. And you still got to have the mechanical cable to shut off if everything else went wrong, at least you can kill the fuel to it and get the thing to shut off. The fire suppression system, pretty good example of a fire here. And if you watch when the truck goes up the hill, and right there he hits the button and the fire goes out, and he got out of that with the truck raced in the next show, and the driver wasn't hurt, and there was no fire suit damage even.
Oh my gosh.
Not sure why his fire suppression didn't go off, or he didn't pull it or whatever. Again, most of these fires, transmission fires, right underneath the driver. When you slow these down and look at them in slow motion or even still, the still shots, it's absolutely just unbelievably frightening.
We have many examples of this, unfortunately.
Shows I've seen all year.
What's going on here? What?
Did he just attempt to? That's an attempt of a reverse backflip.
Is that a front flip?
You got to give it to him. Oh my goodness. Oh my.
Look at the in cab.
They'll shut this down quick. Look at the onboard, and look at how quick. If this is anything, Adam, besides scaring you a little bit, it's a testament to the safety you guys have in there. The cages, the fire restraints, the protection, and the quick release. He's out of there.
He's out. He's done. He's out, man. That's probably the scariest.
He's in there a long time.
There's probably a fire in the truck.
Yeah, you know, with all the safety equipment we've got.
Fortunately, we have so many examples there. So most of these are caused by transmissions. The transmissions, the converters will get hot and blow the seal out of the converter, and the transmission fluid will burp out and ignite. Either the exhaust or anything, but that's and it's right under the driver, so it's a bad spot, and we see it all the time. another in cab here.
And different racers feel comfortable in different layers of fire or different levels of fire suits too. Some racing organizations allow you to allow an SFI 5. MTRA requires at least a 15 because that's what SFI says is best for a methanol fueled closed vehicle. I know there's a lot of guys out there that use 5s. Mark had a 15 in that example of fire that you saw earlier there, and he since has gone to a 20, which is what a nitro funny car guy wears. But the material that it's made out of is modern day stuff now is so flexible, and it's he's as comfortable as he was 20 years ago in an SFI 5. So
yeah, I noticed that Jason commented about the necessity to wear gloves. We'll have an example of that in just a minute that we'll get to. Probably go through these all day, unfortunately. There's the pull for the fire suppression system.
And as a truck owner, you really ought to carry an extra bottle. I know a lot of people don't carry an extra bottle. They think that they're never going to need it. Well, as somebody that has used it, we did carry an extra one. We always, we had it for years. We always carried extra ones and never needed them. But then when we did. And yeah, carry an extra one with you if you're a truck owner.
There's the nozzle mounted under the seat right there with 3 ports.
And it's important that you use the correct amount of nozzles with the fire suppression system. Too many, and the thing won't work with the adequate force. Too few, and you're not going to. Chances are you're going to miss the fire.
That's an example of not wearing a head sock. Flame got under the helmet.
Some people require fire extinguishers, some don't. MTRA likes to see one in there because, if you're at a car crush or you're somewhere by yourself, chances are that, there's not trackside, there may not be fire extinguishers available. So it's good to have your own stuff and have it so you can get at it quickly, but yet substantially mounted so it's not flying around inside the cab as a projectile. The 5-point harness, now they've changed up this tag a little bit, and they put the expiration date on them. They tell you not to use the thing after a specific date, but they're still, now they give you this deal. And I think that's what you're going to see now because all the other tags have expired. See the guy fly out?
Belts failed. Book has diagrams on proper installation and mounting points for the harness.
Mounting the harness correctly is as important as the harness itself. The best harness in the world mounted incorrectly isn't going to do you any good either.
Most common, a ratcheting style. Don't want to see that. The angle needs to be straight. That gives it a point to tear.
And there's different types of buckles, the latch and link, the cam locks. There's different styles.
Basilar skull fracture is the most common way that race car drivers have been killed over the years. And I realized that in the crash, the torso is restrained, the head is unrestrained and moves forward. If I could counteract that motion of the head, then I could restrain the head relative to the torso, reduce the neck tension, and essentially eliminate the motions and forces that cause this basilar skull fracture.
Your neck moves an unbelievable amount when your body stops and your head keeps going.
Yeah, here's an example of that exact thing.
Unbelievable.
Look at this landing right here. Look at his head. Almost hit his lap. That can result, I think it's called, is it called virtual decapitation, where your spine is detached from the base of your skull?
And add a helmet to the weight of your head, and you're dealing with even more significant.
The side-by-side comparison, same truck, same jump, or very similar jumps. Top is with a conventional neck collar and bottom with a Hans or a head and neck restraint. What's the landing?
No fuel, batteries, radiators, water hoses in the driver's compartment. Pretty obvious. If there's hoses coming into the driver's compartment, whether it's like if a steering hoses pass through there or something, wrap it, shield it so that it can't spray on the driver if the fitting breaks or the hose fails. Those cheap white plastic oil pressure gauge hoses that come from the parts store when you buy your oil pressure gauge, those belong in the trash. Don't use those. Screw a fitting on there with a number 3 or 4 line or something, braided steel line. Some organizations even require you to shield that. So that plastic hose there, just don't even give it a shot. We want to make sure that the engine only starts in park and neutral. If it's in reverse or second high gear or whatever, it won't start. Only in park and neutral. The throttle toe strap, again, going back to that push-pull cable, if for some reason the throttle does stick down, something goes wrong with the toe strap, you got a second chance to pull it back up. That's the toe strap right there. It goes around the driver's driving shoe so they can pull that throttle back up.
These are just some areas of concern that we don't have verbiage in the rule book, but some of this stuff is fairly common sense, but still, adequate protection around the fuel cell. A good example of a crash. Look at the fuel cell. Look at all that fuel being dumped out. Many examples of that. Those things are durable, but they're not indestructible. So having adequate shielding around the tank, tubing placement this is actually illustrating something that you don't often think about, but it is an issue once you run into it. Sometimes when you get upside down, even if it's a minor thing, if you don't have a proper reservoir for your transmission, the fluid pours right down into the cab and it can catch fire and catch you strapped in. So having a catch can for your transmission fluid is also important.
And check the vent on that, because that's what caused our fire. We had a catch can and no vent, backed up and blew the dipstick out of the transmission. When the transmission couldn't vent, blew the dipstick out, and oil was sprayed on the headers and it started the fire.
Tethers on the sway bar arms, when the sway bars snap, the arms can become detached, or they'll bounce around. The tires can get them, and the tires can fling them. So that's not a terribly uncommon failure. At least the restraint keeps it contained to the chassis. That's a wrap to keep the pieces from, because when they shatter, they turn into splinters. So they've got a wrap to try to keep that contained. These are boots around the driveline. They're driveline blankets that go around the U-joint shields to contain the smaller parts. So, the cages will keep the main parts of the drive shaft there, but when you have the cap, the U-joint caps and things like that, these blankets do a good job of keeping those parts right there under the truck or inside the blanket rather than being slung out at high speed.
Yeah, they got a couple different sizes for different ends of the drive shaft.
There's a cap laying on the ground, expelled from a truck. Tethers on the driveline loops, that's a really good idea, because if you lose a driveline or if you break one end, they can drop and catch the ground and then be ripped off, and then now you got more pieces hanging. So having a tether that keeps that cage suspended, even if there's a driveline failure, is really important. See there, without that thing would be laying on the ground.
Everybody's seen the really cheap tires that are available out there for sale, and you gotta, some of them are great deals and some of them not so much.
Yeah, this is just to give an example of even a small tire, how catastrophic a tire failure can be. And then you have and that's not a whole lot of volume you're looking at there as compared to a tear tire.
And look at this situation.
And they're not aware of the danger is the problem. Sure, many of you have seen this, our little experiment. Can't even begin to, there's no way video will convey how loud and impactful that was. I mean, it sounded like we were quite a distance away in the shop when it went off, and it was like a bomb went off. It shook the whole building.
So the bottom line is we really got to watch these cheap tires that are out there and the age of tires. And we even have a board member that experienced this firsthand. Scott, tell us about this situation.
So yeah, we were basically just airing up what essentially was a spare tire for the team. It wasn't even one that we used. Normally it was just our spare that we kept at the shop there. And getting ready to go into the summer season, and we just want to make sure that we had everything ready to go. So aired the tire up. It was kind of low, and not up against the rims. It had kind of leaked down. So we were airing it up, getting it to seat against the edge of the rims and stuff like that, and it did. But what we noticed is that it's a two-piece rim, and there was some air leaking out of the two pieces, and a couple of those bolts were loose. So no big deal. Roll the tire up close to the shop there where we could get at it with we had a little bucket there that we kept those, spare pieces of those bolts and washers there for the rims, and took that out there, and we were just tightening those bolts down that had kind of come loose, and blam, the part of that tire there, you can see it just slipped over the edge of the wheel, and all that air came out and threw me back about 5 feet into the side of Roger's truck there that you could see that was parked next to the tire. And basically, you can see there that damage to that tire was stuff that we couldn't see. And when we started using that tire, it didn't show that. And so, and when it developed or whatever, we never noticed that. And so that right there that's what allowed the tire to, slip over the rim. You can kind of see the marks, on the left side of where that damage is, where it just slipped right over the rim and, drug some of the powder coating with it. But cost me about half of or a third of my skull, and a bunch of other damage, and a hand that's partially unusable, and a lot of other things. I'm thankful that I'm still here. But one of the things that I've learned through this, and by the way, this is a tire that I bought for us to use. It was a 6-ply tire. It matched other 6-plies that we use, and me being the dorky engineer, I wanted to have, the 6-plies with the 6-plies on one side versus the other. So I bought that tire to use. It didn't look bad when I bought it. But moving forward, this is, as you can see, it's an older 6-ply. I don't think we need to be using tires that are 20, over 23 years old. I think we've developed in respect as a motorsport that we are, that we need to be using more up-to-date stuff. You go to a demolition derby cars run newer tires than 23 years old. And so I just want us to learn what I've went through, and basically make some changes as to how, a lot of us do things. And that, if we got a nice piece of equipment, maybe use tires that are a little bit newer than 20 some odd old fertilizer spreader tires that have been wandering around in fields.
Yeah, very quickly, I want to point out that some of the issue was caused by, like, some of this cracking that you see on the sidewall allows moisture to get down in the tire, and it gets down into the bead. So the bead rust, there are metal cords in there, and the bead burst, and that allowed the bead to expand and slip over the rim and cause all this issue. These type of things are really not visible from the outside, and unfortunately a lot of times we see a lot of used tires for sale. And I can tell you from personal experience that a lot of times the best looking tires that you find, at on a farm or something, the reason that they look good is because the tire was damaged and they took it out of service. This was a big issue at the time. And as a result of Scott's accident, we investigated more and we found that that was more common than we realized, that there had been other cases that had just not gotten as much attention. And then cases where tires have let go on this, while a truck was on display and things like that. And we recognize that, again, if it can happen, it eventually will. We feel that we need to do something to keep this from happening and hurting somebody in the future. We recognize that this is probably not a popular idea, but when you consider the investment, a modern monster truck where you're talking a couple $100,000 investment, and yet some guys feel that it's okay to use a $300 tire on something that, that will spend tens of thousands of dollars on things that are not necessarily as, potentially dangerous as this. I think the time has come for us to implement at least some basic rules to move this forward that we can improve upon over time. But we spent a lot of time talking about this issue. We've been talking about this issue for several years now. And obviously COVID played a role in pushing this back some. And there was a lot of pushback just from the rumors that we were, of things that we were talking about doing. People saying, oh, this is going to be the end of monster truck industry because they want to do away with used tires. Like, first of all, we're not saying we want to get rid of used tires, but we need to do something. We can't, in good conscience, allow something that's a legitimate concern to go unchecked. So, through many, many discussions, and I'm sorry I kind of took over here, Scott, but I know it's because we're a little short on time, and I think that we need to get to the point of this. And, these bead issues and everything, and then the other issues like overinflation issues. We found this has happened so many times. Tires, people, and a lot of us are guilty of it. You put the air check on the tire and you get a phone call and you step away, and the next thing you know, there's a catastrophic failure. And we've had numerous cases of trailers being blown apart, like what you see here. I mean, these things are bombs when that happens. So, and then not to mention the numerous fatalities there's been in the agricultural business related to these things. And again, so then when we see these tires for sale, in various places that are, who knows where they came from, a lot of times people don't even know how to inspect them. And that's not even counting the fact that some of these weaknesses are not visible externally. So we tried to come up with a way to address this. What can we do? And the only thing we've been able to come up with at this point is a date range for the tire, right? Some type of a way to draw a line in the sand, right? And say a tire, and I'm going through the pictures rapidly because we're almost out of time. And this is something I feel is very, very important. I think Scott's the one that did the research on this, on how the tires are coded based on their date range.
That's correct.
And we recognize that could be complicated. Looking at it like, okay, how do I reconcile this? How do I look at this date and understand, well, what is this telling me? And we understand that could be overwhelming. But one thing that stood out is that in the year 2000, the codes changed. They went from a 3-digit code to a 4-digit code. So we said, well, maybe that's the key. If you see 4 digits, it's at least from the year 2000 up. Where if it's got a 3-digit code, it's prior to 2099 and back. Could go all the way back to the 70s for all we know, or actually late 60s.
Yeah.
And again, there's no way to know what the history of these things are, how long they sat out, why they were taken out of services, all these different things. So what we're suggesting and we're contemplating implementing is a date limit, and say, what, at least if we go to a requirement of a 4-digit code, we know that the tire is maximum of 23 years old. It's not a perfect system, but at least it's a start that maybe we can work from there and maybe develop a better system. But at least it's something. At least we feel like we're doing something about this issue. On top of that, on the inflation issues, we've researched regulators that could be put in line on the compressor lines that will bleed off. You could set it. I mean, it's a kind of actually a useful thing because you could set it, That's another thing that we glossed over quickly that I want to point out is that when this failure happened with Scott, that tire only had like 12 psi, if I'm not mistaken, right? 12 psi when it went off.
It was not very high.
Yeah. So it doesn't require, you're talking a lot of volume where we don't need a lot of pressure. And the thing is, a lot of these modern tires that we're running run much higher pressures than that. So, the idea of having a regulator that's set, like you set it and forget it, you set it with a screwdriver or something, is a good idea because then you can lock the chuck on the tire and walk away, and you're not going to overinflate that tire. It's just reducing the chances of something happening by accident. We try to focus on the things that are within our control, not the things that are outside of our control. So this is another thing we heavily frowned upon, using ether to inflate tires in a hurry. Unfortunately, we had way more stuff to cover. We just don't have enough time. There's just so much to all of this. That's why we figured that we were going to have to do follow-ups. We want to get as much input from everybody out there as possible. The idea of doing this and making it open to everyone is to emphasize the fact that our objective is to make this industry as safe as possible. It's not anything we're doing for any personal gain. We're not trying to manipulate the system for our advantage in any way. This is only to help everybody, to help the spectators, to help the competitors, the crews, everybody. So
and thanks for working through us with everybody with our, as we're learning this technology.
Yeah, we'll be better next time.
Yeah, but it's important we get these discussions or get these things out there, and even if people walk away and they talk about, well, I was at this thing last night and I saw this and I hadn't really thought about that, but and you encounter inspectors. I see some of our guys that we encounter at US Hot Rod are on, and that's cool. That we personally encounter. And we often have discussions, amongst ourselves there with things that we see and maybe at other types of events, and that maybe we don't see at Monster Jam, or we do see at Monster Jam, we didn't see somewhere else, whatever. But I think everybody agrees that the safety is everybody's deal, and you can't learn enough from it. If US Hot Rod is very good about sharing stuff with the Monster Truck Racing Association when they encounter something. Hey, you better look at this. We saw this happen. You better look at this. So that's very, very. It's very much appreciated too. That it's a two-way street. And I've gone to some of their guys and said, "Hey, watch this video, or this is something that was sent to MTRA. You should look at this." And they do. They do. It's not like where they blow us off. They do. So it's important that for everybody's sake that we try to continue to make this safe as we can. And
one of the things I want to point out, and this is one of the big things that it's unfortunate we didn't get to, and I think this in itself is sufficient reason to have a follow-up on this is, and I touched on this earlier, that over the past 30 plus years that the MTRA has been developing these new, these safety protocol equipment, the trucks have reached a point where they're pretty safe. I mean, they really are. I mean, the failures are starting to be limited to very small areas, and that we can focus and try to come up with better solutions for. But in general, what we're seeing is the concerns are more the environment that the trucks are operating in. So event safety and event safety protocol is the single biggest area of concern right now. And there are so many different areas. We have an entirely different presentation for that, with examples of things that people just don't think about, placement of the staff, placement of the stands where the spectators are situated, direction of travel. There's so many different facets of the things that you don't ever think about that can come back and, bites you in the butt. You know, there's so many things. So yes, we'll definitely do a follow-up, because I saw that Bubba was asking about a promoter and using MTRA rules and guidelines for inspectors and all. That's a whole, that's going to be another presentation. I think that's something we need to do. We are also, you know, I mentioned earlier that the organization is trying to evolve and modernize. The industry is completely different than it was when the organization was established. So we want to adapt. And in order for the organization to survive, because the organization does have, you know, have financial, you know, requirements for us to be able to continue to do this. So we have to be creative in how we operate. You know, at one time, the industry was comprised of hundreds of independent teams that all, you know, showed quite a bit of support for the organization. Today, there are only a handful of independent teams. And so it's difficult for us to, you know, survive on just their assistance. So we're, you know, we have to adapt and get smaller, cut our overhead down, and try to do things in a different way. Maybe rely on support from the, you know, the industry associates, you know, people that work in the industry, people that are fans of the industry and all. So we're going to be talking about different approaches on how we can improve that. There are, you know, maybe different ways on how the inspection processes will be conducted. How, you know, and that's an area where we kind of would like to get more input from the you know, the public on how they would like to see some of these things done. Sometimes we can't see the forest from the trees. You know, we're in these environments all the time, and sometimes, you know, the obvious can elude us because we're just so focused on us, you know, on a certain perspective that we have, that sometimes it takes eyes from the outside that are looking at it more objectively and can spot things that we're overlooking. So that's where all of you that are here tonight showed that you believe that this is something important. It's something worth, you know, spending time with, and we would like to encourage that as much as possible. I'm just going through some quick questions. I see that Sean is asking about track building designs and stuff. Yeah, that's something that will be in the event safety presentation, because again, spectator placement is really critical, especially when you have things to consider like these, you know, wheel restraint failures and things like that, where wheels are getting away. We have a whole bunch of presentation on that. That's a whole giant area of conversation. Joss was asking about 4-link material, aluminum bars. Yes, the MTRA is open to new technologies. We don't, you know, we don't want to discourage people from trying to improve, but we ask that it is done in conjunction with the MTRA, that we can authorize the use of certain things for testing purposes, because we do want to, you know, we never want to limit the creativity. That's what this industry was founded on, was creativity. When all of us started, that was what it was all about, is expressing ourselves mechanically through this equipment that almost had a personality. And that's the one thing that we never want to lose in this industry, that this is an expression of individuality. There's a question about ride trucks. That's an area that we often don't spend enough time. I mean, admittedly, don't spend enough time discussing. Even though they're moving slow and, you know, they're in a different type of environment, that's an area that deserves quite a bit of attention. Paul is asking about advantages of the blower 10% overdrive. That is a whole nother big area. That is something that we've been talking about for the last couple of years. And that is, again, modernizing the organization for today's environment. Back when the 10%, the 572 cubic inch, 10% overdrive, well, it was originally 20% overdrive and then rolled back to 10%, rules were established, we were dealing with trucks that had very limited suspension, ill handling. There were a lot of reasons why we tried to define, okay, well, what is a safe horsepower range for a truck to operate, given the environment of the day. Today is different. Obviously, the trucks are much more capable, but horsepower is not the name of the game anymore. Now it's reliability. All the trucks are capable of running at a pretty high level. So how do we conform to this new environment? The other thing that has changed is the hot rodders of the 80s and 70s and even up into the 90s. That was all about cubic inches and blowers and turbos and things like that. Today, the technology is vastly different. It's about efficiency. And these newer generation motors are smaller displacement, much higher efficiency, smaller superchargers with much greater efficiency, fuel efficiency, exhaust particulate, improvements, where they're more environmentally conscious, if you can, if that's even a thing, So we feel that we need to adapt to that. We need to modify our rules to allow for the new technology, the LS motors and the Godzilla motors and these modern technologies, smaller cubic inch engines. But in order for them to be able to perform on the same level, we have to change things like our blower rules, allowing screw type blowers, they're smaller and boost levels are different, but effectively we're still talking engines in the same horsepower range, but they're capable of doing that. Let's just to put a number on, let's say we're talking in the 1500 horsepower range. You can achieve that with a big cubic inch motor with this big 871 blower on it, or you can do that with this little 400 cubic inch motor with a much more efficient induction system that can put out that 1500 horsepower vastly more reliable. Almost, we've been talking, you can buy crate motors that'll put out 1200 horsepower that have a 100,000-mile warranty. So we need to be looking at that. We cannot stagnate. We've stagnated for too long. We need to get modernized. But doing that, again, requires a lot of input, and different perspectives. How can we develop rules that we don't let these things run away from us, that all of a sudden we've created a monster that somehow in the way we created these rules, we allowed for a 2,500, 3,000 horse truck, not that that's any particular advantage. We've found, and I think Tim knows this better than anybody, that the high horsepower truck can actually work against you. The drivetrains that we have developed over the past, call it 30 years, since, probably since the 90s, were kind of designed around that 1,700 horsepower threshold. You get much above that and the reliability just tanks, which is great for, straight line drag racing in here. But again, for the environment that we perform in today, that's not the ideal combination. We need reliability, repeatability, and all these other things. So that's the future. That's definitely conversations we will be having. And I hope, again, to get everybody's input on this stuff, and that, if we deem that this tonight was successful, we hope to be able to do this on a regular basis and have this dialogue between everybody. We had the chat, we had the, shut down, or not the chat, but the microphone shut off because we didn't want too many people talking all at once. But that's something that we can work on, where we can allow members or people involved to be able to speak and give us their ideas. We can unmute people one at a time to get this conversation moving forward. I'm sorry I'm rambling on. I know we're over time and everything, but there's just so much that we needed to cover. And this was an experiment. We knew that it normally takes us a full day to be able to convey this information, but we knew that was not realistic in the, doing it in this format. So hopefully we can get feedback from you guys. On social media is probably our Facebook page would probably be the best place for you to give us your thoughts about this. How can we improve this? Ideas. Well, why have you tried this? Other ways for us to improve the communication between us and the community. We will, again, in the future, I think we're going to rely heavily on the community for support to allow us to continue to be able to do this and, be the conscious for the industry. It's a sad fact that, the promoters might look out for themselves, but they're not necessarily looking out for the entire industry. We're the only ones that are looking out for the entire industry. We treat everybody the same. So with that, Tim, do you have anything to add?
I don't believe so. Thanks everybody for participating. And I know, if any of you, like he said, any of you have ideas, for crying out loud, send them to us. Better ways to do this. We're just learning. We're trying. Nobody gets paid to do this. Everybody's just trying to keep the industry moving forward, keep it safe for everyone. The crew guys, I saw some chat things coming up there about crew guys. Just keep it safe for everybody so that we can keep doing it. We can't have buildings saying, well, you can't, well, we don't want them things in our building anymore. We can't have that, or racetracks or state fairs or whatever. We need to be in as many of these venues as we can, and that requires everybody to do absolutely everything they can to the vehicles, to themselves, to keep ourselves in the right place when people tell us to move and don't be in this place or whatever. But we gotta do our best to get out of the way and do what they ask to keep everything moving forward safely for everybody. So appreciate everybody coming on with us tonight. And it was a big experiment. It was a good one. I think we learned something. So we'll try our best to keep moving.
Thank you, everybody. Appreciate your participation. We look forward to hearing from you. Good night.